This is the session you've all been waiting for. You're here because you want to do 3 things. Number 1, learn about the AWS DeepRacer. Number 2, have fun and get stuck into machine learning. And number 3, find out how you can win some awesome prizes. So, it's a great pleasure to welcome you all to today's session, where we kickstart your machine learning journey by going hands-on with AWS DeepRacer. I'm Aileen Liu, a Business Development Associate at AWS, and I'll be your presenter for today. My DeepRacer journey started 2 years ago when I was at the start of my own machine learning journey, and it helped me tremendously because it was a practical application of the concepts and I could see them in action. Since then, I've helped thousands of DeepRacer enthusiasts get started, and I can't wait to share my passion with all of you today. In today's session, we'll start off with an introduction to the AWS DeepRacer, and I'll also show you what it looks like. We'll explore the concept of artificial intelligence and the 3 different types of machine learning. Then, we'll dive deeper into reinforcement learning, so you can learn how the DeepRacer is able to make decisions in real time. After the theoretical content, I'll show you how it all fits together by going through a demo in the AWS console. You'll be able to follow me step by step and see how I create, train, and submit a model. And, saving the best till last, you'll want to stick around for some exciting changes to the AWS DeepRacer League in 2022 and see how you can win some awesome prizes. Just a hint, you might be going to Vegas. Machine learning can be complex, but we're here to make it simpler. With the AWS DeepRacer, builders from all skill levels can get hands-on machine learning experience and learn the basics of reinforcement learning. You'll discover the foundational components of AWS DeepRacer, apply your new skills by building your first model, and you will have a chance to submit your model to the world's first global autonomous racing league. AWS DeepRacer is your ticket to improving your machine learning skills because you get to apply machine learning concepts, build models, and then see them in action. The AWS DeepRacer literally puts reinforcement learning in the hands of everyday developers like yourselves, regardless of your machine learning skill levels. Now, introducing the AWS DeepRacer. What you see here is the original DeepRacer that was launched in 2018. And here I have with me the new and improved DeepRacer Evo. It's a 1/18 scale 4-wheel drive with a monster truck chassis. It uses an Intel Atom processor and Intel distribution of the OpenVINO toolkit. We have 2 of these 4-megapixel stereo cameras, and this LiDAR sensor on the top is a light detection and ranging sensor that has a 360-degree and 12-meter scanning radius. This car is configurable, so although it comes with 2 cameras, you can remove one and you can also choose to turn the LiDAR on or off with minimal effort. Because the new DeepRacer Evo comes with a LiDAR sensor and stereo camera, these new features enhance the DeepRacer's learning ability, which gives you more challenges to solve. If you do happen to have the classic AWS DeepRacer, you can buy a sensor kit which will upgrade to Evo functionality. But the great thing is, you don't have to own a physical DeepRacer to participate. So let's say bye to the Evo for now. Everyone can start in the AWS console as there's a 3D simulator where the building, training, and racing takes place. The AWS DeepRacer League is the world's first global autonomous racing league. Each year, tens of thousands of developers from over 150 countries compete in the league for a chance at prizes and glory on the world stage. You'll find out more information about the brand new league division for 2022 at the end. If you're not ready to climb the leaderboard and take on the top pros just yet, or if you just want to race with friends, you can start a league of your own with the Community Racing tool, which allows you to build models to race against friends and colleagues. This section focuses on reinforcement learning, which is the machine learning that powers the AWS DeepRacer. But first, we're going to start with artificial intelligence. Artificial intelligence, or AI, is a broad concept, but in general, it seeks to create machines that seem to have human intelligence. As humans, we're good at learning how to classify things or events, and we can also make simple predictions based on past behavior. Machine learning is a subset of AI that aims to replicate this human ability. It uses statistical techniques to build models that are good at making predictions, and these statistical techniques learn from the data to figure out what the patterns are that ultimately lead to the prediction. Within machine learning, there are three categories: supervised learning, unsupervised learning, and reinforcement learning, all of which can be deployed in the real world. First, we have supervised learning, which is about building a model to predict a value or classify data. These models are trained using huge amounts of curated training data that have labels attached to them. For example, let's say we feed this model thousands of images of cats. These images are all different, some zoomed in, some blurry, black cats, white cats, tabby cats, the whole lot. And these images have all been labelled cat. As the model continues to train over time, it'll learn what a cat is. And then once it's trained, if you feed the model an image, it can tell you whether it's a cat or not. In unsupervised learning, models are trained to identify similarities in large amounts of data to help with classification. Unlike supervised learning, the training data that's being fed into this model doesn't have explicit labels of, let's say, a cat. Instead, the model is trained over time to classify similar images together. For example, if you feed an image of a cat into this model, the model will put it into a pile of cats based on similar physical features of cats. In this case, the model can't tell you that it's a cat. Lastly, we have reinforcement learning, where models are trained to autonomously predict which decisions to make in an environment. The model learns based on the outcomes of whether the actions were good or bad, and this is what the AWS DeepRacer uses. Did you know that reinforcement learning is built on an idea that we as humans actually use all the time? For example, pocket money for completing chores, offering small children ice cream to stop them from crying or throwing a tantrum. Let's think about the methods used to train a dog. We give treats for good behaviour, and we don't give treats for bad behaviour. Dogs quickly learn what they should or should not do to get that treat. If you're successful, your training turns a regular dog into a circus dog. Now, let's go through some key terms. Within the simulator, we have an agent, which is a piece of software that acts autonomously in an environment to reach a specified goal. In our case, the agent is the AWS DeepRacer vehicle, and the goal is to finish a lap around the track. The environment is the surrounding area our agent interacts within. In our case, this is the 2022 Summit Speedway track. The state is defined as the current position within the environment that's visible or known to the agent. Basically, this is what the agent can see through its camera, which gives it an indication of what it should do next. The agent starts off at the starting line on the track, which is its initial state, and the agent learns by taking a photo of its environment, where each photo it takes is one state. For every state, our agent needs to take an action to try and achieve its goal of making a lap. And depending on which action it takes in a given state, it'll be given a reward. If the chosen action gets the agent closer to the goal, you can reinforce this action in the future through a positive reward or otherwise discourage it with either a negative reward or no reward at all. This reward is provided by the environment itself and is specified through a reward function that's written in code. This incentivizes behavior through parameters defined by you. We'll go through a sample reward function later during the demo. The last concept here is an episode, which represents each iteration where an agent goes from the start position to a termination state. A termination state just means it either drove off the track or finished a lap around the track. So, to summarize, your agent, the DeepRacer, is learning in an environment through trial and error using feedback. This feedback is in the form of rewards that are given for its actions. And you want your agent to take actions that will accumulate the highest rewards. The key is the reward function. Without the reward function, you won't be able to incentivize particular behaviors for reinforcement learning. As humans, we know that the best and the quickest way to the goal here is via the orange path. But our DeepRacer agent doesn't know this, so we need to help it explore so we can figure that out. This race grid will illustrate a practical example of a reward function. Each square is a state, and the green square is the starting position, also known as the initial state, and the finish line is the goal, also known as the termination state. Now remember, if you exit the track at any stage, it's also a termination state. The black squares at the top and bottom are the track edges and defined as stop states, which will tell the vehicle it's gone off the track and failed. The reward function helps the agent determine if the action it just took was good or bad, and how good or bad it was is based on the outcome. As the agent moves towards the goal, the next state is evaluated and assigned a reward. This reward incentivizes the driving behavior you want your agent to learn. So now the question is, how can we incentivize the agent to drive on the orange center line? To help it explore, we hypothetically assign each of these squares a reward. The squares in the orange path get a reward of 2 because it's the best path, so we're telling it to take actions that allow it to stay on this line. 0.2 is still a valid reward because it's a valid path, just not the best one. Anything that has an X in it means the DeepRacer has gone out of the track, and so it gets no reward. When our agent first starts, it won't know what the rewards are in each of the squares, so it won't have any idea of the actions to take to get it to higher rewards. So, it needs to explore the environment in an iterative way to build up this knowledge. Through reinforcement learning, the car will learn which action results in the highest cumulative reward on the way to the goal. By assigning a high reward of 2 to the center line, our model will learn that actions that allow it to stay on the center line earn higher rewards than actions that lead to driving on the sides. Now let's see this in action. Learning doesn't just happen on the first go. Initially, the DeepRacer agent doesn't know what the best path is, so it has to explore through trial and error to figure that out. Each time it starts to when it exits, that's an episode. For each episode, it'll add up the reward points that it gets. For example, 2.4, 4.2, and so from multiple iterations, it'll eventually converge to the highest reward possible. The DeepRacer will finally learn that it can get the highest score possible, which is 18, by going straight on the orange path. It also records each step. So the state it started in, the action it took, the reward it received, and the next state in its memory. So it's learning what rewards the various actions from a specific state lead to. Eventually, it reaches convergence, where the model starts to frequently pick specific actions based on the state it is in. This is a first-person view of what you can expect to see during exploration. It's normal for the agent to go off the track. It's exploring the track to figure out how to get the best rewards from different actions in different states. As the agent gains more and more experience through exploration and iteration, it starts learning where it repeatedly gets higher rewards. It then starts exploring less and moves on to exploiting what it has learnt. Now let's talk about the training process, which in the end produces a model that navigates the track for the highest reward. The car interacts with the simulated racetrack environment during training with an overall goal to get to the finish line while maximizing its total reward. It drives around the track, taking 15 pictures per second that represent the states. After each picture, the DeepRacer will take an action, like changing the speed or the steering angle. Because the DeepRacer Evo has stereo cameras and LiDAR, it has a more in-depth view of its state and can sense objects as well. When the car ends up in a new state, it receives a reward based on the action it chose. Learning is a repetitive process and is generally 20 episodes around the track. You control the amount of episodes using hyperparameters that you set. The more it goes around the track, the more experience and knowledge it collects. The more knowledge the model collects, the smarter it becomes and is able to figure out which actions in which states lead to the largest cumulative rewards, and it uses that knowledge in future driving decisions. Once training is finished, you have a model that can be uploaded to a real AWS DeepRacer vehicle that will then use that model to navigate a physical track in the real world. Now, let's go a little deeper. The DeepRacer uses a neural network architecture with multiple layers. Think of it as a way to extract patterns from images, trying to figure out which actions lead to the best reward. The first layer is an input layer, which is an image also known as the state. As I mentioned before, the state is basically what the agent can see through its camera, which gives it an indication of what it should do next. From this input layer, the captured pixels go through a 3-layer convolutional neural network, also known as a CNN, to help identify the features from the images needed to make driving decisions. This includes things like the track border, the field, and the track surface. Then, it feeds those features into a second neural network, the policy network. This helps determine what action or driving decision should be made. For example, should the car speed up, slow down, turn left, or turn right? And that's the final output. The policy network adjusts the weightings to help determine what action to take, and these weightings are just the level of importance given to the input values and features in order to determine the action. I mentioned in the beginning, the DeepRacer uses an Intel distribution of the OpenVINO toolkit. This is a free software toolkit to help speed up AI and deep learning workloads. It means you can take the reinforcement learning models you've trained and use the toolkit's model optimizer to convert and optimize your trained model. Then, you can use the OpenVINO inference engine to deduce actions as the DeepRacer races around the real-world track. The inference engine allows you to deploy on the Intel Atom processor. Now, let's turn theory into practice. This is the DeepRacer simulator architecture. When you start training a model in AWS DeepRacer, it links together an Amazon SageMaker container and an AWS RoboMaker container. It then passes the right parameters to start the training and to generate experience with the state, action, new state, and rewards. After this experience is obtained, it's sent back to Amazon SageMaker to train the model. The new model is then sent back to AWS RoboMaker to get more experience, and the process continues. The output models are stored in Amazon S3, the videos are streamed via Amazon Kinesis video streams, and the metrics are stored in Amazon CloudWatch. You can then download the model and run it on a physical DeepRacer. This is a first-person view as the DeepRacer drives down the track, and these are the parameters that are defined in the track environment. The main components are the track wall, the field, the track surface, the track boundaries, which are the two white lines around the track surface, and the track center. We also provide waypoints, spread around the track as a series of XY points, to give some hints on the shape of the track. The waypoints help us programmatically determine how much of the track the DeepRacer has completed. We can use these variables to build our reward function. Also important to call out here is that these variables are given by the simulator when we're training the model. When writing your reward function, you can choose to include the heading parameter, which describes the orientation of the vehicle in degrees measured counterclockwise from the x-axis of the coordinate system. Another helpful parameter is the all wheels on track parameter that indicates if the agent is on the track and returns true or false. The distance from the center parameter indicates how far away the vehicle is from the center line. There are also other variables available to you that you can use to build your reward function. When you get to the AWS console, this is what the DeepRacer landing page looks like. To get started, let's head over to this panel on the left here where your garage is located. This is where you'll be configuring the vehicle specifications for your DeepRacer model. Let's go ahead and build a new vehicle. First, give your vehicle a cool name. I'm going to name mine Sydney Summit DR. I would recommend establishing a naming system if you decide to create multiple vehicles. Next, choose your favorite color. I'm going to choose black. Next, we get to the cameras and sensors. You can choose between a single lens camera or a stereo camera. Stereo cameras will help with your DeepRacer's performance in head-to-head or object avoidance races. However, for a simple time trial race, which is what I'm doing, a single lens camera is sufficient. LiDAR sensors will also help with head-to-head and object avoidance races, so I won't be needing it here. You've now created your first vehicle. Next, we're going to create a model. First, give your model a name. Again, I would recommend a naming system if you're creating multiple models. You can also add in a little description here to remind yourself what the model is. The track that we'll be using is the Summit Speedway track, but you can see all the tracks that have been used in the past. Next, we'll be choosing the race type. I'll be choosing a time trial race, but you can choose from any of the 3 options. You can also preset the training algorithm and hyperparameters here. However, I would recommend leaving these as default until you become more familiar with your reward function. Next, our action space. These are the actions the DeepRacer can take, which are preset and defined here. Once you start training, you won't be able to change this action space. Now, the action space can be continuous or discrete. In a continuous action space setting, the agent learns to pick the optimal speed and steering values from the minimum and maximum bounds you provide. There's a range of values for the model to pick from, but it means the training time is also longer. With the discrete option, you set the granularity, which limits the number of speed and steering angles the agent can have. I'll be choosing the continuous action space option. Next, choose the vehicle you previously created. Now, the reward function. The DeepRacer uses Python 3 syntax. As I mentioned, there are 4 preset reward functions that you can use. There are 3 for time trial and 1 for object avoidance and head-to-head. For example, in this reward function, we're rewarding the agent to follow the center line using the track width and distance from center parameters. If you choose to modify the code, you can also validate it. The next step is to set a training time. Ideally, set them in smaller increments because if your reward function isn't ideal, or your hyperparameters aren't ideal, you could be providing your DeepRacer with a poor training environment, so you don't want to be training your models for 12 hours in that poor environment. And yes, I'll submit this model to the DeepRacer League to try and win some prizes. Finally, you can create your model. It does take a few hours for your model to train, so let's check out a model I created earlier in My Models in the left-hand panel. My model here has finished training, so the reward graph is static, but as your model trains, you'll be able to see a reward graph that continually updates, and you'll also be able to see a live simulation video stream. The reward graph shows you the average reward the DeepRacer is getting and its average completion percentage, so ideally, you want that percentage completion to be trending upwards and as high as possible. Once your model finishes training, you can click the Start New Evaluation button. This tests to see how well your model will go. Once finished, your results will show up here. So there you have it, you've officially trained a model. If you think your model is a winner or has strong potential, you can clone it and build on what it's learnt. Okay, you've waited long enough. Let's talk prizes and competition. The AWS DeepRacer League is back and better than ever in 2022 with 4 divisions, so you have even more ways to compete and win this year. First, the AWS DeepRacer League virtual circuit returns with monthly races from March to October. All races start in the open division competing in time trial. Time trial models are the easiest to train, making the open division a great place for you to kick off. Every month you compete in the AWS DeepRacer League, you receive exclusive digital rewards to add to your garage. When making new models, you can select the special rewards you have earned to customize your car, and it'll show up in your race runs. The top 10% of races in the open division each month advance into the Pro division, where racers compete monthly. Every racer that makes it to the Pro division gets a Pro welcome kit with exclusive AWS DeepRacer gear like sweatshirts, stickers, socks, hats, and more surprises. Each month in the Pro division, the top 16 racers compete live on Twitch. If you're in the top 10 at the end of this race, you win an AWS DeepRacer and it's shipped directly to you. Now, this is what's really exciting. The top 3 racers in each month's Pro finale win an all-expenses-paid trip to AWS reInvent at Vegas. You'll be racing physical AWS DeepRacer devices on the all-new and longest ever 2022 Summit Speedway track. The top 2 competitors at each Summit event will advance to a regional playoff. so you can compete at Sydney Summit and have the chance to represent Australia and New Zealand on the global stage. You'll join other top racers from their corner of the globe for a chance at one of 15 trips to reInvent by competing live on Twitch. And we have the all-new AWS DeepRacer Student League. Each month, March to September, participants can train a model to the AWS DeepRacer Student League for a chance to compete for prizes such as DeepRacer devices, scholarship cash, and even a chance to win a trip to reInvent. What's unique about the Student League is that all students have access to the same amount of training time each month. This ensures an equitable playing field for all participants and will force students to strategically think about how they can top the leaderboard. There are several resources out there to help you get started with AWS DeepRacer. I'd also encourage you to get engaged with our training and certification content to continue your machine learning journey. So today, you learnt about what the AWS DeepRacer is, what reinforcement learning is, how you can train your DeepRacer and get a model submitted. Once you get a model submitted, believe me, you will not want to stop. You'll enjoy spending time experimenting and tweaking your reward function to move even just milliseconds up the leaderboard. As I mentioned, you don't need a physical car to start training and racing, you can do it all virtually. So, drive on over to the DeepRacer console, get on the track and race for prizes and glory, and we'll see you at the finish line. Thank you so much for watching. We really value your feedback to help us improve our sessions, so please share your rating today.